Hello. For final project number 2, I've chosen tic-tac-toe, which is a fun game, and I've chosen case 2, where I have programmed a computer AI using the Minimax algorithm to make sure that the computer never loses. Here's a brief run through of my program as I'm compiling it right now. Okay, so here, empty board user is X and computer is O, current board is this. Enter your move, row, column, and here the coordinates. So let's say I just want to go in the middle by playing 1-1. Okay, now the computer plays here, which is automatic using a minimax algorithm. Now let's say I just want to play 2-2. Now here, now it wants to play here. Okay, I think it wants to make this 3, so I'll go 1, 0. And the computer wins in this case. Now let's say I want to draw. Now if I want to draw, now I go, let's say 0, 0. Okay, the computer plays 0. I want to go 0, 1. There. Now the computer plays here. Now I'm going to go 2, 0 here. And now the computer plays there. Now I'm going to go 1, 2 here. And then 2, 2. So this is a no-winner and draw. As you can see, the computer can never lose, and it can either draw or win. So let's see how this program works. So first I have include iString using namespace std, and now I have a character matrix board 3 3. Those are the dimensions, 3 by 3 game board. Now this is how I fill in the game with dots. So I have a nested for loop with 3 by 3, 0 to 3, 0 to 2 in index, but 3 columns and 3 rows. So here I have board ij equals a period which assigns each index from a row and column to a dot. Now this is void print board. This is when initialize board is when every game starts, then it's gonna initialize this board. Now here's a print board function because I can't print the board manually every single time. It's better to keep it in a function. So let's say cout current board, and then I output the board. It doesn't matter what's in the board, I just output it, board ij, and then I have new row with cout endo, so it displays in proper columns and rows. Now here is a check if P has a winning line. So how can I check if the player has a winning line? Well, this is using the minimax algorithm. Now here I could check if all possible cases. So I0, board I1, and board I2. So this is basically the rows and columns. And now this is the rows and columns. And then I have board 0i, this and this. So I don't need to write it for every single row, column, or else I needed to write 6 of this. Then I need to just write for I, and then when I run the program, I could just look for I and see if there's anything in the row or anything in that column. If there is a winning possibility, then I could just say that the computer can just put a X as the remaining spot. So here, checking diagonals, it's the same process, except there's basically only 2 diagonals, so I don't need to check I. So I could just basically directly specify the coordinates. And I return true if this is true, return true if this is true, and then return false. That means the computer is okay, there's no threats. Now check if the board is full. This is when I'm gonna get a draw, right? So if all the coordinates are not this, then that means return false. Else return true. So to see if there's full, I can just check if everything is not. I could check either if everything is not a dot, or it's better to check if there is a dot, I could just set a flag as false. If there is not a dot found, that means all locations have been already taken, so I'll return true. Now, how do I handle user move? Well, I could just simply use a function with print statement, enter your move, and then I could see I have to the most important thing is checking if the position or the board value is either true, is valid or not. So here I could say if it goes over the boundaries, which is lesser than 0 or greater than 2, then I could just say invalid move, try again, or else this is saying user, this is your move, break. Now here I have recursive minimax algorithm. So I could see if winner is winner 0, that means if there's any row, column, or diagonal occupied with O, that means that we return -1, that means computer wins, and if there's X, then we return -1, that means user wins. If it's full, then draw, and that's returning 0. Now, here's a computer's best score is computer -1000 to 1000. So this is basically to see try all moves. So now let's see trying all moves. For int I equals 0, we could brute force the computer's choices. So we could see if we could go through all the computer's choices and see if the computer faces any of these problems. As we could see here, is winner. If we see if there's any of those problems. Now, as the computer is programmed with the minimax algorithm, we could just say we have the minimax function here, and now we could just put it into void computer move. So when the computer moves, and now we could just go through the all the index of the position. If there is this and there's this, that means int score equals minimax false. Board ij is dot. That means that we're not going to put anything there. If it is true, then that means the computer's move will be there. Now this is updating the rest. Now here we output the computer's move, and this is the main game move. Basically, I initialize the board, then print the board. While true, this is my main while loop that goes through the entire program until it's done. That means that if I have a winner, then user wins. If it's full, see out no winner, draw. So this is just checking if is winner is X and is full, draw. And now here, if computer move, that I output the computer's move every single run, and I print the board after every single run of the computer's move. Now here I see if computer wins, this computer win. If it's O, as computer is O, result computer wins. If it's full, no result, no, and no winner and draw. And after that, I just return 0, and the program successfully completes. Thank you for listening. This is my project number 2. I'll later present my bonus project for final project number 1. And